So I'm gonna solve some problems from my partial exam. The first one is the following. If a ball covers a d distance in a t time, how much distance does it cover in half that time? So for this we're gonna use our cinematic equation, which equals a d, which is the one it's gonna get to, equals 0 because it starts at a 0 distance, plus a 0 velocity because it starts from rest. This is also something that I didn't write here, but the problem tells us, plus 1/2 of gt squared. So if t equals halves, what do? We just write a 1/2 in here, all right? t halves, all right? So when we do the math here, we basically get a 1/4 outside gt squared, which would equal to 1/4 of the distance, all right? And this is because this term is squared, so if we want to make t squared, we also have to make the 2 squared, which will give us a 4, and then the equation divided by 4 means that the distance gets divided by 4. So that's how we would conclude that the answer would be the following. All right, so next question. The next question talks about centripetal acceleration, and it's actually pretty simple. So what it says is the following. Let me read it for you. A cyclist runs along a circular track, all right, with a constant speed of 20 meters per second, all right? But the problem also tells us that the radius of the track equals 40 meters, all right? So what it asks us is the following. What is the centripetal acceleration of the cyclist? So for this question, we have the following formula. Centripetal acceleration equals velocity squared divided by the radius. All right? So we got, it's pretty simple. We just have to substitute it, and we get over here, we get, well, 20 squared divided by 40. And when we do this operation, we get a result of 10 meters per second squared centripetal acceleration, all right? So pretty simple. Let's move on to problem number 3. So this problem talks about speed, well, velocity and acceleration, and when we are given 2 equations, which are the following. First equation, x equals 7t squared minus 7t plus 6, all right? And the second one is y equals 4t to the third minus 3t squared minus 12t minus 5. So what the question asks us, which I'm not going to write down just for the purpose of convenience, is when the velocity in x equals 0, how much is the acceleration in y? So we know a bunch of things for this. The first derivative of the position, by the way, these equations are position vectors. So we know that the first derivative of the position equals speed, and the second derivative of the position equals acceleration. So basically what we would need to do is do the first derivative of this one and do 2 derivatives of this one, and then kind of sort out our variables, obviously by equaling this one to 0, because that was the problem state. Then do the math and figure out what the value of y is. Alright, so let's do it. First derivative of x, it equals 14t minus 7t, that is the velocity in x, alright? So then we have to do 2 derivatives for y, alright? So I'm gonna go ahead and do them. First one, here we go. Velocity in y equals 12t squared minus 6t minus 12, alright? So there we go. Sorry, just let me fix one thing, which is this one. because we got 7t, so when we do the derivative we lose the variable that doesn't have an exponent. So then we have to do this one again. Acceleration in y equals 24t minus 6, alright? So this is our equation for acceleration, and this one is our equation for speed, which we will equal to 0 now, alright? 0, there we go. And in order to solve this, we basically just have to get the time variable out of this and plug it into this equation, and then we will get the value of acceleration in y. Pretty simple, right? So this equals 7 divided by 14. 7 divided by 14 equals t, alright? Which equals 1/2. Alright, so we have to plug this into this equation, and we get that acceleration in y equals 12, because it's 1/2 of 24. 12 minus 6, which equals 6 meters per second squared. Alright, so that's it for our problem number 3. Let's move on to problem number 4. Problem number 4 states the following. It's kind of similar to what we did in problem number 2. So this one also talks about centripetal acceleration, and it gives us the following information. A truck enters a curve with a radius of 150 meters, alright? And it's got a maximum speed of 32 meters per second, alright? And it says, for the same acceleration, what would be its maximum speed at a radius of 75 meters. So what we have to do first here is use our formula for centripetal acceleration to calculate an acceleration, which we are then gonna substitute in another formula, the same formula actually, but with this speed, and we don't know with this radius, and we don't know the maximum speed, right? So we're gonna find it out pretty simply. So this is our equation, as you might remember. V squared divided by the radius equals the acceleration, alright? So we're gonna do this for our first case. We simply have to substitute 32 meters per second squared divided by the radius, and this gives us a value, which I already pre-calculated for you, of 6.83 meters per second squared. Alright, so that's our first value for acceleration, which we are then going to plug into our second equation, and we got 6.83 equals velocity squared divided by 75 meters. Pretty simple. So we just have to do the algebra, and we are left with the following equation. It is the square root of 75 times 6.83, which equals a value of 22.6 meters per second. So that is the maximum speed at which this car can go when the radius is 75 meters. Alright, so that's how we would do this problem. And okay, we got one final problem, and this problem is also about centripetal acceleration. So for the final problem, we got the following. An object is experiencing both centripetal and tangential acceleration. Which of the following statements is true? So first I'm gonna draw the situation for you. Let's suppose we have a curve, well, a circle here, and we got our object that's moving. And it's experiencing this tangent acceleration to the curve that it's moving in, and it's also experiencing this acceleration here. They're both accelerations, right? And this one basically will determine how fast the object is moving around the curve, and this one will basically keep it moving in a curve. So first of all, the options which state a straight line, we can already get out of the equation, because we are experiencing a centripetal acceleration towards the center, which, well, not really, but you know, we're experiencing a centripetal acceleration, and that will keep it moving in a curve. So this one and this one we can already count out. Then it's experiencing an acceleration, right? Oh, here's another straight line. So that leaves us only with two options, and because it's experiencing an acceleration, a tangential acceleration, but an acceleration whatsoever, it can't be going at a constant speed. So we're only left with option D, which says that it's moving in a curve and a negative acceleration. We don't really know if the acceleration is positive or negative given the information in the problem, but we do know that it is an acceleration, and therefore it is letter D. Thank you very much. Bye.